your taster day. And what they did was, they, I think, did Gaz call it the sum to n? And then wrote them in an opposite direction. And then added them up together, so you've got two lots of the sum to n. So you have an n plus 1 plus an n plus 1 plus an n plus 1. And so you could see that 2 times the sum of the first n terms, n integers, is n lots of this, isn't it? So, yeah, remember? Right. Could you write down a heading in your exercise books, please? So standard sum of series. Right, we have 3 standard sums of series that you're going to work with. The first one you will not be told and you will have to learn, but it's just that one of the sum of the first n terms. So writing that using sigma. Now you've met sigma before, haven't you? Right. I think, did you meet it as well when we did that sort of whistle-stop tour through series? That is saying, so we tend to like to use our general term as R. So what that means is R is going to take 1, R is going to take 2, R is going to take 3, all the way until R takes n. Does that make sense? Yeah? So it is the sum of the first n integers. You know that it's that. You will be expected to know that. You are then going to have 2 other results that will be on your formulae booklet, right? And you will get, in A-level maths, you won't get a formulae booklet, you just have 2 pages at the front of your maths exam. In A2 further maths, you get a huge formulae booklet. So you'll have a formulae booklet for that. These next 2 are going to be on that formulae booklet, in that formulae booklet. And we've missed out the first bit of this chapter, which is proof by induction with summation. And the reason for that is it's something that we're going to do. What we're doing today isn't going to be that difficult, so it's easy for people who aren't here to catch up. So I'm now going to give you 2 results that you will be told, and you will be able to prove them by induction. But not today. So your second result is going to be sum of the first r squares. So that's going to be 1 squared, add 2 squared, add 3 squared, all the way to n squared. And this is going to be n over 6, 2n plus 1, n plus 1. Again, you're going to be told that in the exam. And your last formula is the sum of the first n cubed numbers. And that formula is this expression squared. So again, you will be told this. It's n squared over 4 times n plus 1 all squared. Right, there are things that you need to know about your summation. And once you've done this chapter, hello?
Just the r cubed, is that not the r squared?
No. just going to have to wait. We'll prove it by induction. Okay, just wait. Have a little patience, Tom. So yes, so you will be told them, and we're going to prove them by induction with the rest of the class when they come back and you've done proof, because you haven't done any proof by induction with summation. That's what this chapter is going to be about as well. Okay, just trust me, Tom. Right? Just trust. It's going to be okay. Right. Interestingly, after you've done this chapter, you're going to be able to prove your standard deviation formulae from your stats in normal maths. To be able to go from your formula to the one that we, know and love, you need to be able to work with series. So you haven't had the maths before to prove that result. Okay, 3 things that you need to know. You may want to write them down. They sort of reasonably commonsensical, so you maybe don't feel that you need to. You can split up a sum or a difference with your summation. So very simply, if you had the sum of something like r squared plus r from 1 to n, that can be split up into 2 separate summations. Right, so you can split up a sum or a difference of your summations. That's the first thing. The second thing, you can take out constant factors. You know when you're doing your integration, it's really handy, well I think it's really handy, to take out a constant outside your integral. Well, really similar idea with your summation. So if you had the sum, and I'll use a general constant here of c. So say you were finding, say it was like the sum of 3r. You can take out the constant. I.e. the sum of 3r is 3, times the sum of r. And you'll find one of the first things that starts to go is the whole n and r equals 1. We start abbreviating it and just putting a 1 there. Then we stop putting them on, and then we realise we need them there. So a constant can come out. And the more important thing that you might not instantly think of, but this is really useful, if you find the sum of a constant term from 1 to r, you are just literally going to add up that constant n times. It's turned into an e, that's a little c, and you are going to have n times. So that would be nc. So if you were to find the sum of 3 from r equals 1 to n, that's going to be 3n. Is that clear? All good so far? I'll do one example that's not particularly difficult. So A. Find an expression for the sum from r equals 1 to n of r bracket 3r plus 2. And we will expect our answer to be given in fully factorised form. It may well state that. That's an n there that looks a little bit r-like. So first thing I'm going to do is expand my bracket. now I'm going to split up my summations. So you can see how often during a question we might abandon the r equals 1 and n and maybe put it back on at the end. Using my laws of summation, I know I can take out that 3 and I can take out that 2. You are then going to go to your formula booklet. You are going to use the sum of r squared. So I've replaced the sum of r squared. I am now, having learned the sum of r, I replace that. So what I'm now going to do, so I'll stay in the video, is go to the top here. Right, I know the 3/6 is a half, so what have I got? I've got n over 2, 2n plus 1, n plus 1, plus n plus 1. Are you with me? And now I'm going to take out, I'm going to write in fully factorised form. So, Tom, common factors please.
Oh, n plus 1.
Yeah.
And n.
Okay, well done. Let's take out a factor of a half as well. So that's going to leave me in this first term just a really nice 2n plus 1. And in the second term, it's going to leave me, if I take out the n and n plus 1 and divide by a half, it's going to leave me with a 2. Are you with me? So my answer in fully factorised form is a really neat okay, part B. Hence, find the sum from r equals 1 to r equals 2n, and I've changed my n to a capital just to make it more interesting. So all you're going to do is take your formula and replace the lowercase n with capital 2n. Is that clear? So you're going to get 2n over 2, 2n plus 1, and 2 times 2n. So it's going to be n 2n plus 1, 4n plus 3.